Okay, we're going to solve the next exercise. Exercise is a number 1.28. If an object is near the surface of the Earth, the variation of its weight with distance from the center of the Earth can often be neglected. The acceleration due to gravity at sea level is g equal to 9.81 meters per square seconds. The radius of the Earth is 6,370 kilometers. The weight of an object at sea level is mg, where m is its mass. At what height above the surface of the Earth does the weight of the object decrease to 0.99 mg? Alright, now then, I'm going to write down the information that the problem is given to me. So we are talking about we are talking about International System Unit, so 9.81 meters per square seconds. The radius of the Earth is equal to 6,370 kilometers. The weight of an object, we already know that is equal to mg, mass multiplied by the gravity. At what height above the surface of the Earth? So they are talking or asking to me about an height. Does the weight of the object decrease to, so the weight is equal to 0.99 mg. I'm going to use an equation that gives a relation between an height above the surface of the Earth, the gravity, and principally the radius of the Earth, which is this one. The weight is equal to mg multiplied by re divided by r. These two evaluated to the second power, in which this is the weight, this is the radius of the Earth, and this is the distance between the center of the Earth and the object that is above the surface of the Earth. In this case, this weight is equal to 0.99 mg, as we can notice here. This is equal to mg multiplied by re divided by re plus h, which is the value that they are asking to me, the distance between the surface and the object. Those two evaluated to the second power. Now, because of this mg is equal to this mg, I could eliminate both of them. And now the equation at this point is as follows: 0.99 equal to re divided by re plus h to the second power. Then right here I'm going to evaluate both sides of the equation with an square root, so I could eliminate this power of the second power. So the answer is 0.99 equal to re divided by re plus h. And then I have to solve the equation for h. So I'm going to do it step by step for you to not get confused. So I'm going to send this part to multiply the other part of the equation. So re plus h multiplying 0.99 equal to re, and right here I have I'm going to send the square root of 0.99 to divide the re. So re plus h is equal to re divided by square root of 0.99, and then I'm going to send the other RE to subtract the division. This is the answer of the problem. Now 6,700 and what? I'm sorry, 370 divided by the square root of 0.99 minus 6,370 is equal to 32.0908 kilometers. Why kilometers? Because this RE is given in kilometers and this 2, and this has no units. I always use, if you are asking to yourself, I always use for significant digits after the comma or the point, so that is why I'm writing the result as this. And that's it, guys. That is the result. Now, why did I use this equation? Because I want it, or because it was necessary, or where this equation comes from? Now, right here is the part of the explanation that in which I'm going to give some different physics principles that was necessary to be explained or to be known for this exercise to be solved. Now, when we have two particles separated by a specific distance, which I'm going to call the distance r, and I'm going to call the mass of the first particle m2 and the mass of the second particle m1 and the mass of the second particle m2, there is going to be generated a force, an attraction force between them that is equal for the two of them. That force is equal to a constant g multiplied by m1 multiplied by m2 divided by r to the second power. This is what Isaac Newton said. Now, starting from this equation is what we're going to do for us to get to this equation. Now, because we are talking about a planet or a moon or a gravitational field, and I have, for example, a particle on the surface of the planet, in the case of the Earth at sea level, the center of the planet is going to pull the particle or the object using the gravitational force. So in this case, this equation, this part of the equation, is going to be given by the constant multiplied by the mass of the particle multiplied by the mass of the Earth divided by the, in this case, the distance between the two of them. So that is equal, in this case, to the radius of the Earth evaluated to a second power. Now, there is another equation that has to be taken into account, which is a force, because of Newton's second law, is given by a mass multiplied by an acceleration. In this case, the force is the weight and is the same as this force. So a mass multiplied by acceleration is this one. Which mass? The mass of the particle. Which acceleration? The acceleration due to gravity. Now, because of these and these are the same, I could eliminate both of them, because I could send this value that is multiplying two other values to divide the other part of the equation, so I could eliminate. Now the equation at this point look like this. Now, because I'm sorry, this A, you're right, is the gravitational acceleration. In the case of the Earth, is equal to 9.81 meters per square seconds, and in the case of the US customary base units, it is equal to 32.2 feet per square seconds. Now this G, because it's a constant, is equal to 6.67 times 10 to the minus 11, and this is important part of this, newtons multiplied by square meters divided by square kilograms. And I'm going to multiply it by the mass of the Earth, which is given in kilograms. Now, because of this, I could change the upper side of the division of the equation to this. Why is that? Because I could play with these units. So a Newton is a force, so it is necessarily a mass multiplied by an acceleration. So in the case of the international system units, it is kilograms multiplied by meters per square seconds. Then I'm going to multiply by square meters. Then I'm going to multiply divided by kilograms to the second power, and then I'm going to multiply this by kilograms. And right here I'm going to equal these units to these units, which are a gravity, which is an acceleration, so meters per square seconds, multiplied by a distance to the second power, so meters to the second power. Then this is the same thing as having meters to the third power divided by square seconds, right? Now, if I eliminate these kilograms with these two, these kilograms with these kilograms, and I multiplied these two units, I'll have meters to the third power divided by square seconds. The same thing as here. So now we have get to this part, or to this equation. What is the difference between this one and this one? The mass. So I'm going to multiply both sides of the equation by the mass, and here I'll have mass times an acceleration, which is a force, which is in this case the weight. And right here I'm going to write I'll just reorder the equation. So R. So right here, because of those two r being evaluated to the second power is the same thing as having this. Remember, this is the distance from the center of the earth to the particle, and it could be applied to a particle that is not on the surface. It could be applied to a particle that is above it. So particle P, center of the earth. Right here I have RE, and right here I'm going to move it for explanation purposes. I have R. Now this H is the same thing as having R minus RE. So if I reorder this, RE is equal to R minus H. I'm sorry, I didn't want to do this. I wanna solve it for R. So R is equal to H plus RE. Now guys, this is how this exercise could be solved.